In this video, we're going to look at another special kind of sequences, and these are considered geometric sequences. And geometric sequences represent a set of numbers that follow an exponential pattern, which basically means that if I wrote out this sequence to get from one number to the next, we're going to multiply by the same value every single time. Notice how we said multiply by the same number, not divide. So if I was technically dividing by 2 every single time, I'd have to look at this in terms of what I multiply by, which is technically I'm multiplying by 1/2 every time. Now, which means that recursively, a geometric sequence, to get from one number to the next, you take the previous term and then just times it by whatever the common ratio is, which is that thing that you multiply by called r. The explicit form of a geometric sequence is these things follow an exponential pattern. Their explicit form looks like an exponential function where you take the first term, a1, times your common ratio raised to the n minus 1 power. And so let's use this information and let's look at our first geometric sequence and let's do some things with it. So I'm given the geometric sequence, -3, 12, -48, 192. And one of the first things we want to do is figure out what the next two terms are. So to go from -3 to 12, and then from 12 to -48, and then -48 to 192, we're multiplying by -4 each time. So it times by -4. So what that means is I know r is equal to -4. So to get my next number, I would need to take 192, and I would need to multiply 192 by -4. And so the next term is going to be -768. And then the number after it, I would turn around and multiply by -4 again, and we wind up getting 3072, and then that would continue on. Recursively, since all we're doing is multiplying by -4 each time, we have to define what the first number is in the sequence. So a1 is equal to -3. And then to get from one number to the next, an would equal the previous term, an minus 1, times r, which in this case is -4. The explicit formula, let's say I wanted to know any particular term without generating the whole thing. The explicit formula, an equals a1 times r to the n minus 1 power. Well, we know a1 is -3. So explicitly, this would be -3 times -4 raised to the n minus 1 power. To find the 8th term, we would take our explicit equation, we put in 8 for the n, and we would evaluate. So the 8th term, a8, would equal -3 times -4 raised to the 8 minus 1 power. And then we would evaluate that to see what we would get. And so our 8th term would come out to be 49,152. All right, so now we're going to be given two terms of a geometric sequence, and we want to figure out what the first 3 terms were and also what the explicit formula is. So let's say I'm given, so over here on the left, I'm given 2 terms. I'm given the 5th term and the 6th term. And I want to find, let's start with the explicit equation. Well, the explicit formula for a geometric sequence is an is equal to a1 times r to the n minus 1 power. Now let's think about what it is we're given. So we're given the 5th term is 324. So a5 is equal to 324. And since we're told that it's geometric, we know that the 6th term, a6, is going to equal a5 times whatever r is. Well, I don't know what r is, and I want to figure it out. So if I'm given 2 consecutive terms, r would equal, in this case, a6 divided by a5, and that would tell me exactly what r is. And so you divide 972 by 324, and we get r is going to be -3. So I have r is -3 right out of the gate just because I could divide 2 consecutive terms to see what I multiply by. So explicitly, all we have left to do is to find that first term. So an is equal to a1 times -3 to the n minus 1 power. Well, pick a term to use. I'm going to pick the smallest term that we have, which in terms of term number, so a5. a5 is 324, and I'm going to solve for the first term, and what I'm going to do is I'm going to put in 5 for the n's. And so our 5th term, a5, would equal the first term times negative 3 raised to the 5 minus 1 power, which so basically I had to take negative 3, raise it to the 4th power, times it to a1, and that would give me my 5th term. Well, a5 was 324. We don't know what a1 is. That's what we want to know. So times negative 3 to the 4th power. So we take 324, divide that. Negative 3 to the 4th power is 81, and we wind up getting the first term to be 4. And so our explicitly defined function would be an equals 4 times negative 3 to the n minus 1 power. Now, we wanted to write the first 3 terms. Well, we know that the first term was 4. To get to the second number, I would take 4 and multiply it by my r, which r was negative 3, so 4 times negative 3 makes negative 12. And then to get my third term, I'd multiply negative 12 by negative 3, which gives me positive 36. That's the first 3 numbers generated by that sequence. Now let's look over here on the right-hand side. I'm given 2 random terms again. I'm given 2 non-consecutive terms, the second term and the 5th term, and let's go figure out what the explicit formula is. And then we worried about what the first 3 terms were. So we're going to do a little different approach. So the explicit equation for a geometric sequence is an is equal to a1 times r to the n minus 1 power. Well, we're given a2 and a5. So I'm going to take the highest index term number, a5, and I'm going to put that where an is. So I'm going to say a5 is equal to, and then I'm going to take the earliest term, known term number, which in this case is a2, and put that where a1 was. So a5 is going to equal a2 times r raised to the, well, how many times did I have to apply r to get to 5? Well, an easier way to look at this is I had n minus 1. I changed the n to 5 and the 1 to 2, so it'd be r to the 5 minus 2 power, or I could just think logically and say, to get from the second to the 5th term, I'd have to multiply r 3 times to get there. 5 minus 2 is 3. So we're going to resubstitute in. a5 was 3 over 64. a2 was 3 over 8. And so times r to the 3rd. And then we would work our way and we'd solve. So we'd have to, we'd multiply the 8, multiply by 8, divide by 3, and we'd wind up getting 1/8 is equal to r to the 3rd power. You take the cubed root of both sides, we get r is equal to 1/2. So now I know what r is. So I know r is 1/2. Now we can go through and we will need to go find our first term. Well, if I know that a2 is equal to 3 over 8, I had to multiply a1 by 1/2 to get there. So that means that a1, if I do take 3/8 and divide it by 1/2, that means I can go backwards. And so that means a1 was 3/4. And so our explicitly defined function would be an is equal to 3/4 times 1/2 raised to the n minus 1 power. Now, let's go write out our first 3 terms. So a1 was 3 over 4. Our second term, multiply that by 1/2, it should be 3 over 8 because that's what's given, and it is. And then multiply by 1/2 again, and that would give us our third term to be 3 over 16. Those are the first 3 numbers in that sequence.